So can observe refraction with lenses. So here I have a convex lens. That means it's fatter in the middle than on the ends, so it bows out like this. And this is a double convex, means both sides are bowed like that. And so what we have here is a converging lens. So the light source, which is down here at the bottom of the screen, the light's coming in the incident rays, and they're going to go through the lens and form a focal point. The incident light is here. It goes into the lens and it refracts. So the light slows down and then it converges to a focal point. So let me just put a dot here and I can do the same thing here. Real close. But at the base of your screen, if you look, I'm going to move it a little bit so you can see it. You see those little lines? See the little lines? They're very thin and very light. They're right down in here. Okay. A convex lens or a converging lens can also magnify images. Now I can't really show it to you here, but I can show you that the image would be right in here. Converging lenses, as you can see, the light comes from one side and converges on the other side of the lens. Except for when it magnifies. When it magnifies, the image will be on the same side of the lens as the light source. But that's something we'll talk about in class. The incoming light is here. So these are our incident rays. These are our refracted rays. I'll use RF, or it should be little t. And they refract into a focal point way on this end. This is called F. Okay. This would be the focal distance between the center of the lens to that focal point. I mentioned about magnification. Okay, if the focal point of this lens was here, if we put an image inside here, it would actually get magnified like this, and it would be right in this area. That's those little small lights lines that I showed you.